Engineering Science, Mr. Young here, back with another systems video. This time this is a lead on from the Universal Systems Diagram video. We're looking a bit more in depth actually. We're taking the systems that we saw in the first video, the Universal Systems Diagram, and we're breaking it down slightly. We're looking more in depth into it. So this is actually called top level systems and subsystems, and we'll look at this over the next course of whatever it is, 9-10 minutes in this case. This is applicable for S3 through to the end of N5. It also comes up at higher as well, so this is ideal for anyone that's studying engineering science at S3 level through to at least higher level as well. So it'll be a lead on from the Universal Systems Diagram. So you'll be looking at inputs and outputs, and you'll be looking at how the energy transformation between one input into the output. So bear with us, check it out, and see if you can follow along. Thanks.
Okay, so looking this time at top level system diagrams and some subsystem diagrams as well. Now there's a difference between two of them. Obviously the first one is very similar to the one that we found out before, which was run out of room. Typical. That one. Very shortly done. You see how the rest of this video is going to go after the start of that is. So looking at input, process and output, which we said was a universal systems diagram. It's the basic foundation of all system diagrams, so electrical and engineers, mechanical, any other type of engineer, before they start building an object or looking at building a product, they will break it down and look and see what the inputs are and what the outputs are going to be and what they need to make it happen. So there's no point in making a new phone and buying loads of motors for it when you don't really need a motor for a phone. So they need to break down and see what they need in terms of inputs with regards to how is it going to be powered, and outputs, what's it actually going to do, the output, what's it going to show, what's it going to do, what's it going to move, is it going to light up or make a noise. So relevant to everything that we have in our world today. Okay, so top level systems diagram is just basically looking at this kind of thing here, looking at the inputs and outputs. So what are the inputs, what is it that's in the middle here to begin with, and what are the outputs. Now this is at the sort of most basic level here. If I take an example here, because I brought one in of this, I don't know if you can see it very well, this light up toy. This actually spins around and should light up. Now downside is I've replaced the batteries on this and it doesn't quite work anymore, so that's why I'm just using this as an example today. So you can see there's wee LEDs, I don't know if I can show you that, wee LEDs there. This head moves around, so there must be something that makes this head spin around, and there's a wee slide switch here and the battery compartment. So if I take that off, you can see already, you know it's going to be a battery in there. But if we're looking at this in terms of systems, if I put that to the side a second, we know that it's a battery, so we're going to call that a kind of chemical input. You could claim it, you can argue it's an electrical input, but batteries are kind of got a chemical mix in them. Another input was that switch. Make that eye a bit easier to see. And I'll just put light up toy here. So what did we say in the output? Light, so we maybe got an LED for light. We might have some sound. We don't really know if we've got some sound because it doesn't work anymore, but I'm just going to imagine if there's a thing that's making this head move, that there's going to be some sort of whirring noise, even if it's very quiet. We'll have, to make this move, I'm going to guess just now, we'll check in a wee minute, that there's going to be some sort of motor that will spin to make that rotate. So motor, and that will give us some kinetic energy because it's moving. And we may have some heat because the LEDs will give off a wee bit of heat. The motor turning will give off a wee bit of heat. So that's the top level systems diagram. So just claiming or just looking at the inputs, what the object is, and the outputs and energy outputs as well here. So that's pretty good. So we can break these down into subsystems, because if we've got LEDs here and we've got a motor here, there needs to be something that's going to make these work. There's going to have to be something that powers these. So let's break this down. Let's have a look inside this light up toy. So you can see here straight away that, and I'll try and pry this open. Try and do this gently. Now, under no circumstance am I asking you lovely people to start tearing your parents' products apart. I don't want them to come in and shout at you for taking your laptop apart because I told you to. Obviously, I didn't. And my name's not Mr. Young, it'll be Mr. Ravy at that point. You can blame him. But you can see here, as we said, the motor and the switch is here. So what I actually do is, probably not in this video here, but I'm going to take a wee bit of, I'm going to prise these out, and I'm going to reuse these, and I'll bring them back to show you what I've done with them actually, because this is quite useful. A wee resistor there as well to protect the motor from burning out. That's what we're saying resistors are for, remember earlier on. And this obviously goes to some sort of switch here. I can take this bit off, but this is a good kind of start. So what we're looking at is, when we're looking at doing subsystems, if I move this out of the way again, is that we're going to have some sort of inputs here. So we've got our input. So we've got our chemical input. And I'm going to put the switch now in here. The switch is actually part of the system. Now the switch is going to operate two different things here actually, and in fact what I'm going to try and do is I'm going to do it each way. So what I'm going to claim here is that there has to be something that's going to make this motor spin here. So there's a motor, and that's going to give us kinetic energy. It's a motor like you saw here. So this is a subsystem here. I'll only do a couple. There's one there, and there's one here. So this is for the motor output. So what I'm going to say here is that there's some sort of driver, something that's giving you enough power to make the motor turn. And I'm going to claim that I'm going to say that's a transducer driver. TD stands for transducer driver. Obviously get input and output transducers. So inputs are your switches, your LDR, your sort of tilt switches, etc. Your thermistors, and you get output transducers, which are your motors, your lights, etc. as well. So this is a transducer driver. This is something that gives you enough power to power the motor. And you can think of this simply, it's not always the case, but you can think of this simply in this case as a transistor circuit. Maybe there's a wee transistor that's helping power this, giving that enough power to turn that motor. So it'll need a certain amount of power, it's not just going to come from the battery. So TD in this case stands for transducer driver, and you'll have a lot of these just before the output. So this will be a common thing, because when we come to do the LEDs now, and again switch is going to operate these ones at the same time. So switch again. I should always learn to make my boxes bigger. There's no shame, I've got enough room here, so I don't know why I keep doing them really small. Transducer driver again, and then that's going to go to our LEDs. Right, and again you've got your chemical battery input here. And your motor, that's going to give you kinetic energy, etc. Okay, so there are your outputs, turning away, and these are your inputs. So I can actually I'll throw them in boxes as well. Boxes are getting bigger in this end. And obviously what we can do here, what I should have done to begin with, that's kinetic energy. And that's light. And there'll be heat in both of these. I'll leave that off just now because I've kind of come in the way. So transducer driver, that's what the TD stands for. Something that's going to give the outputs enough power to light up or move. Now, that's your subsystem. There's one here and there's one here. Okay, two subsystems in this case. So it's just breaking, it's another level. It's taking this and breaking it down to a sort of finer level. Okay, and in more complex systems it's more relevant because you have lots of things going on and you want to see where it all leads back to. Now this is, the last thing we need to do is put in a systems boundary. Now a systems boundary is a dotted line, just like that. Doesn't really matter, but we're going to put it in because the system boundary is where the system ends and where us as humans interact with it. Okay, so as soon as we click on the switch, we're interacting with that system. So the switch is in the system. We'll try and do this one and not clash into the one above. Again, the system boundary, everything else is in the system boundary. Oh, it's kind of going on that LED bit. I should have moved that further down. I was just worried it was cutting off, you wouldn't be able to see it. So the system's boundary is just, you know, everything that's inside this light up toy. Okay, so your switch is inside of it, the motor's inside of it, the transducer driver is inside of it, the resistor's inside of it as well. The same with this. We don't have to claim everything like, oh, there's a resistor, we need to write this in. We don't need to do that in this case. We're just keeping it, it doesn't have to be so complex. That would come later on if you're doing an electrical circuit next. So you'd link this to your electronics and go, well, I'm going to do an electrical circuit, how would that work? So you'd show a circuit with the battery symbol, and then you'd show maybe the switch symbol, and then you'd show the resistor. I don't know if this is being cut off actually. I'll have to move this up so you can see the resistor. So this would be then taken into an electrical kind of circuit. So this is how systems and electronics link together, because you can combine both of these and work both of them at the same time. Now we're missing some LEDs, so maybe build a circuit here for the motor, saying, well, that's a simple one, isn't it? You've got your switch, you've got your motor, we've got a resistor that we saw. So everything's in there, and we've got a battery power. And you can do the same one with an LED at the end here with the LED symbol, and then you can have one that's maybe combined. How would that work? Okay, so there's only one switch, so both of these are actually going to work at the same time. So there may be just an LED symbol here. Oh, arrows are absolutely shocking. I just don't know. I'm going to have to go back to arrow making school or drawing school. It's just horrendous. So something like that. Okay, so that is the basics of top level systems and subsystems. All right.